All right. Hello, everyone, and welcome to Unit 4, Modeling and Analyzing Quadratic Functions and Data. We are here at the ending of Unit 4 with Lesson 4.18, Correlation and Causation. Here are standards: DSR 10.7, distinguish between correlation and causation, and DSR 10.5, calculate the line of best fit and interpret the correlation coefficient R. Our learning target: I can discover and understand that strong association does not indicate causation conceptually and mathematically by interpreting the value R, the correlation coefficient. A hot question: how can we use statistics in the real world? And here are your notes that will be shared. Put the correlation coefficient in order from the weakest to the strongest, the best, throwing out any that are invalid. I want you guys to pause the video and give that a shot. Remember that correlation coefficients are from -1 to +1. It can be less than or equal. -1 is less than or equal to R, is less than or equal to 1. So R, the correlation coefficient, is between -1 and 1. So anything below -1 or anything above +1 is not a correlation coefficient. So I want to make sure you guys pay attention to that. And then when you're looking at from the weakest to the strongest, just look at the numbers. We don't care if it's positive or negative, just look at the numbers. Okay, so go ahead and pause the video. Welcome back. So let's go ahead and throw out the ones that we can't use. So look, this is -1.2. This is less than -1, so we're going to throw that one out right away. This is 1.001, that's bigger than 1. We're going to cross that one out. This is 1.99. We're going to cross that one out. Now let's put it in order from the smallest to the largest. We're going to look at just the numbers. The smallest out of all of them, 0.07. That's smallest. All right, the next number would be 0.43. And then after that, -0.81. We're just looking at the 81 here, 0.81. Then after that, 0.87. And then the strongest out of all of them is -0.98. Okay, because you're looking at the correlation. 0.98 is very strong. -0.98 is very strong to -1. So that's actually the strongest out of all of them. So when we're putting the correlation coefficients in order, we're just looking at the numbers, the absolute value of the numbers, even though we still have to write the negative when there's a negative. All right, let's take a look at number 2. Anything to cross out? I see 1.99, that needs to go, and that's it. Now let's put them in order. 0.04 is the smallest I see. Put a check next to that. Then -0.199. Yes, it's 3 digits, but 19 is still pretty small compared to 0.32. And then -0.42. And then 0.63. And then -0.65 is stronger than 0.63 because it's still stronger, like if you just look at the 6.65. And that is our answer. So again, when we're putting it in order from the weakest to the strongest, we're not looking at the positive or negatives. We're just looking at the number itself. The closer it is to 1, the stronger it is. Okay? And clear all those drawings. Causation versus correlation. While causation and correlation can exist simultaneously at the same time, correlation does not imply causation. Causation means one thing causes another. In other words, action A causes outcome B. On the other hand, correlation is simply a relationship where action A relates to action B. But one event doesn't necessarily cause the other to happen. When a scatter plot shows a correlation between two variables, even if it's a strong one, there is not necessarily a cause and effect relationship. Both variables could be related to some third variable that actually causes the apparent correlation. An apparent correlation simply could be the result of chance, okay? So you don't have to write all of this down, but an apparent correlation could be the result of chance. Both variables could be related to some third variable. Just because it's correlation doesn't mean it's causation. That's what we need you to understand. All right. So correlation is a statistical way to measure the relationship between two sets of data observed at the same time. Causation means that one thing will cause the other. Remember, correlation does not imply causation, right? There's a correlation between when the sun is out, ice cream sales go up, but it doesn't mean that it causes it. There's a correlation between the sun and getting sunburn. Sun does cause sunburn. So there's a direct causation and correlation. So just see the difference there. All right. Causation or correlation. Example one, as people's happiness levels increase, so does their helpfulness. There's a correlation, but there could be other factors happening here, right? Correlation, not causation. Example two, among babies, those who are held more tend to cry less. There's a correlation, but babies cry for other reasons. Number three, dogs pant to cool themselves down. That is actually a causation. They do that, scientifically proven. And I know this is not true example too, because I had a nephew that was held all the time and he cried a lot. He needed you to stand. Okay, that he wanted you to stand. So there's a third party variable involved. Okay. All right. Let's take a look at example one. During the month of June, the number of new babies, the number of new babies born in Utah Valley Hospital was recorded for a week. Over the same period, the number of cakes sold at Carlos's Bakery in Hoboken, New Jersey was also recorded. What can be said about this correlation? So here it is, and then here's a chart. The number of babies born, a number of cakes sold, number of babies born, a number of cakes sold. What could be said about the correlation? Well, let's look at the correlation. Let's just think about it, how it looks. It's going up to the right, right? So what can we say about the correlation? It's definitely a positive correlation. Is there causation? No causation, right? It could be other factors. It could be a result of chance. It just happens to be a coincidence. Coinkydink. So this is an example. All right, here's example two. Each of these relationships reflect a correlation. Which relationship most likely reflects correlation but not causation? So correlation but not causation. When families go to the pool more often, they use more sunscreen. Well, that's definitely a correlation. And you're going to be out in the sun. So, there's probably a causation here too. When families go to the pool more often, they wash towels more often. Well, there's definitely a correlation. And yeah, you go to the pool, so you're going to be using a lot of towels. So there is a causation there. When families go to the pool more often, they go to the beach more often. There might be a correlation there, but no causation because they might not have a beach nearby, right? They might not like sand. So this Going to the pool doesn't mean that you're going to the beach. So this would be the answer. Correlation, but not causation. All right. Each of these relationships reflects a correlation. Which relationship most likely reflects both a correlation and a causation? So we want both a correlation and a causation. Both a correlation and a causation. Making smoothies more often is associated with wearing sunglasses more often. Okay, interesting. Making smoothies is more often associated with making milkshakes more often. Okay. Making smoothies more often is associated with buying frozen fruit more often. Now, if you're making smoothies more often, what do you need to make a smoothie? Well, you definitely need frozen fruit. So this one right here is a correlation and a causation because you need both. You need frozen fruit to make smoothies. That's the definition of a smoothie. Okay. Measuring correlation. So in measuring correlation, we look at the form. We look at the direction. Is it positive or negative, right? That's when we're saying, is it going up the hill, right? Positive. Or is it going down the hill from left to right? Is it weak to strong? We measure the strength, right? 0 to 1 when it's positive or 0 to -1 when it's negative. And then we also look to see if there are any outliers. Okay, outliers are those numbers. Remember, we talked about that yesterday in the last lesson. So we like to see if there are any outliers. All right, let's look at some more. Positive or negative, positive, negative, or no correlation. Let's look at the first one. The number of hours a plane is in flight and the number of miles flown. I'm going to pause this right here. All right, let's go ahead and take this again. The number of hours an airplane is in flight and the number of miles flown. Positive, negative, or no correlation. All right. So the number of hours an airplane is in flight, that goes up. The number of miles flown also goes up. This is what we would call a positive correlation for sure. The number of hours in flight, so as that goes up, the number of gallons of fuel remaining. Well, the longer you fly, the less fuel you have. So we would call that a negative correlation. One goes up, the other goes down when they go in different directions. The number of hours in flight and the number of passengers. Okay, so as the number of hours in flight goes up, the number of passengers, I don't know that depends. I think that's no correlation, right? It doesn't depend on the other. The size of a jar of baby food and the number of jars a baby will eat. Hmm. If the size gets bigger, the size of the jar, if the size of the jar gets bigger, will the baby eat a lot of jars? Probably not. So there's probably a negative correlation here. The size of a person and the number of fingers he has. I think the fingers is just everyone has the same number of fingers, so there's no correlation here. And the speed of a runner and the number of races she wins. Well, if you're fast, and if you're very fast, you're going to win more races. So I would say that is a positive correlation. Okay, excellent. Does the item in column one cause column two, or are they simply related or neither? So let's go ahead and take a look at this some more. Hot sunny day, ice cream sales rise. They're related, but it does not cause. Go ahead and take a look at all of these. You can actually pause the video right here and see if you guys can answer this. All right, welcome back. The price of a burger goes up, the price of fries go up. Might be related. I don't know if I would say the cost. The larger the shoe size, the higher the RQ. That is not related. The number of hours in social media and the grades in school, that could definitely be related. More hours practicing, I don't know, um, basketball. Improved ability in basketball, there's definitely a cause there. All right, so that's an example of this. Causation, correlation, relation, all of that. A lot of it is kind of taking a look at your common sense. Did the decrease in the number of pirates lead to global warming? So here's the number of pirates as they decreased. The global warming, the average temperature in Celsius, it actually increased. Did that influence lead to global warming? There is a correlation, but it's definitely not a causation. So the answer for this, in case you didn't know, no. There's a third thing party involved here. Definitely not a causation, just a correlation. So that's an example of where you would see a correlation, but no causation. All right. And we just did a lot of examples of causation or correlation. So go ahead and do this really quickly for me. Pause the video. This is your turn. Everyone, make sure you do the your turn. Welcome back. The number of cold, snowy days and the amount of hot chocolate sold at a ski resort. Definitely a correlation. Not causation, because they could be buying hot chocolate for other reasons. The number of miles driven and the amount of gas used. Definitely a causation. The more you drive, the more gas you use. The number of additional calories consumed and amount of weight gained. Well, if you consume more calories, you're going to gain more weight. There's definitely a causation there. I'm working on it. That's Mrs. Hall's New Year's resolution. The age of a child and his or her shoe size. That might be a correlation, but definitely not a causation, because after a while, your shoe size doesn't keep growing and you still keep getting older. The amount of cars a salesperson sells and how much commission he makes. Causation, right? Your commission is directly sold tied to how much you make. The number of cars traveling over a busy holiday weekend and the number of accidents reported. There's definitely a strong correlation, but I don't know that I would say there's a strong that it's a causation, right? It's people's bad driving that makes these accidents. The number of homework assignments turned in and how well an individual does in class. There's a correlation. The reason why I probably wouldn't say causation, because you could be getting zeros in every one of those assignments. But there's definitely a correlation. If you turn in assignments and do it well, your grade will be better. If you turn in nothing. So if there correlation or causation, it just depends on the quality of the work. So I don't know. This one is a debate. Let's go ahead and discuss that in class and see what you guys come up with. And then the annual salary and the blood pressure of men in ages 20 to 60, there's a correlation, very interesting correlation, but not necessarily a causation. All right, let's practice with some logical thinking. The data given below indicates the number of facial tissues, Y, used, and the number of students with colds, X, at school. So here's the picture. All right. Which statement can be concluded about the data? There's a causation between tissues and students with colds. There's a correlation between, but not necessarily a causation between tissues and students with colds. C, the more tissues used, the more students with colds. Well, we can't say that. There's a causation between tissues and colds? No, there is a correlation, but not necessarily a causation. They could be using the tissue for other reasons, right? They could be making a mess. They could be crying, not because they have a cold. Students with colds and the number of tissues used can be described as a blank relationship. What type of relationship do we see here? A linear relationship. Okay. All right. Again, the graph makes it look like these events are closely related, strong correlation, but not necessarily, but they are not causal. One clearly did not influence another. And this is the number of people who drowned by falling into the pool and the films Nicolas Cage appeared in. Okay, that's a weird. I mean, the number of people who drowned in the pool is definitely not a cause of the films Nicolas Cage appeared in. There's a correlation, but there's no causation. Okay, so you have to use your critical thinking skills when you're looking for correlation versus causation. And here is another activity. We talked about this in the other lesson. Match the graph with the best value of R. And here's the scale here at the top. Pause the video and give it a shot. All right. Welcome back. All right, so we want to match this. This one is going up, so we know it's positive. It's very strong. So I would say this is 8 right here for sure. This is 8. This one is also positive. It's going up. Let's look at all the positive. It's pretty strong, but not that strong. So this is 7. This is still positive. I think this is 6. This is strong and it's negative though. It's going down to the right. See, it's going down the slope. So I'd say this is number 1, right? -1 when R is equal to -1. This one is going down. This is probably number 2. This is -0. This is number 3. -0.74. This doesn't seem to have any correlation at all, but it does seem to be going down a little bit. So this must be number 4. And then this one seems to be going up a little bit. And so this must be number 5. Okay. And that's how you do it. All right. Here's example 3. Match the correlation coefficient with the appropriate scatter plot. The line in the scatter plot is the least squares regression line. All right, so just here you have R equals -1 or R equals 0.4. Go ahead and match them up. Pause the video. And welcome back. This is going down to the right. So this must be R equals -1. This is going up and it's not very strong. R equals 0.4. Okay. I hope you guys are getting the hang of this. And here's our summary of what we learned. Memorize your decimal shortcuts. Please do that. Whether a scatter plot shows a correlation between two variables, even if it's a strong one, that's not necessarily a cause and effect relationship. Both variables could be related to some third variable that actually causes the apparent correlation. An apparent correlation could be the result of chance. Okay. Remember, Monday is going to be your review and your test is going to be next week, Tuesday. So please study and please let me know if you have any questions or Miss Matt.